We take both the macroeconomic and the microeconomic view to fully dimension an understanding of what we do. We'll deal with dollars, but keep in mind that dollars are not the only way we measure success or failure. For example, there's no explicit way for us to quantify risk or safety or quality. It's very difficult to count something that does not happen, as it is, for example, in our advocacy for safety. We speak in terms of avoided cost opportunity. We cannot stop a work group from failing to use the changes we have made or slow walking them because they disagree. That's a management problem. That's the subject of another presentation. So let's start from the top. The global gross domestic product, it's 75 trillion. You might think of that as what the world makes every year. Note that the U.S. national debt is slightly larger than its gross domestic product. Similarly, you might notice that the total student debt to the U.S. education industry is slightly larger than the education industry overall. Now, the $1.2 trillion is the sum of all labor and materials, faculty and administrative salaries, energy, land, buildings, computers, security, travel, academic conferences, books, furniture, and so on. But when we break out the facility only component, campus infrastructure as we know it, then we're left with roughly a 300 billion annual spend, which is all products and service. Notice also that our industry builds new square footage at about the same rate as the gross annual revenue of Microsoft Corporation. U of M alone has built or renovated the same amount of square footage as is the gross domestic product of the Central American nation of Belize. That's actually not uncommon among the 60 or so large research universities. So when we claim 2 to 3 billion of avoided cost opportunity for the industry overall, we think that we may be conservative by half. But these are already large numbers, and we don't want to overstate our claims, but neither do we want to understate them. We're careful to say that what U of M gets out of this is a share of what gets done for the industry overall. Again, this number is probably on the lower end if we were to fully realize all the changes that we've made. So I often find it ironic that in an industry that has theoretically infinite life cycle, that our point of view extends to only about 3 years, about the time it takes to design and build a new building. Most of our code wins have been harvested in intervals that are far longer than the average. They're far longer than the average tenure of a college or university president. But we understand that different industries respond to innovation differently. The software industry, of course, is very quick to adapt to a market and sometimes even creates the market. The life sciences industry also engages in licensing activity because of early stage risk. That's innovation speak for fear of a competitor stealing an idea. Oil industries, on the other hand, have a long cycle undertakings with long pipelines associated with geological science and the movement of capital. The faster growth economies in Asia also think more long term than we in the U.S., and it affects our money equations because there are other things that we could do with the money in the same time frame. So much for the time value of money. Let's now get down to the microeconomic view. This is a combined first cost and O&M cost worksheet for a typical $50 million administration or classroom building. It's one of our most common visual tools. We call it the Robin chart because very often we have to tell our story in a very short period of time, such as today. You'll notice that all of the rows here are code wins, and all of the columns here. This is avoided first costs. That would be what AEC realizes, and this would be what plant operations realizes. Note that if we get a little closer here, you'll note that again, we seem to, when you add this all up, you'll find that we've taken 2 to 3% out of the first cost, and we reduced that annual O&M cost for that building about $83,000. So, of course, that building has to be safe and sustainable. And when it's not safe or it's perceived to waste energy or contributes too much greenhouse gases or does not have the security that regulators want, that the public agencies want to see, then regulators step in, usually starting from Washington, where lobbying organizations are concentrated. Over here on the left is the number of federal agencies. Let's get a little closer here. Over here on the left, you'll see the number of federal agencies that were present during 1950s. And over here, you'll see the same number of agencies and their regulations. I find it interesting that all these are the agencies, and they wrote very little. And here we have roughly double the agencies, and they've far exceeded the doubling of the amount of regulations that they promulgate. So you may ask, what do they want to regulate? Oh, by the way, here is the share of the federal government. You can see that of gross domestic product, it was about 8% back in 1900, and up here you can see that it's nearly about 35%. So what do they want to regulate? They want to regulate power outlets, temperature sensors, bicycle parking, labor classification, cybersecurity, transformer efficiency, windows, the sizes, where they're located, how many of them shall there be, building temperature and airflow rates, fire pump testing, campus lighting, millions and millions of other products and services needed on our campuses. We argue that painfully prescriptive standards have reached a point of diminishing returns, and that performance standards, very much like those they have in Europe and elsewhere throughout the world, should be the direction of future standards development. In a freer market, if a company is unsafe or unsustainable, it should be allowed to go out of business. But that's not the view of enforcement and risk managers in City Hall and most market incumbents who gain financially from getting their remedy for that problem written into public law. That much said, there's hardly an industry in the United States that is not trying to reduce federal regulation at the same time it tries to benefit from it. So let's start adding all this up. When you look at all the ANSI, at least the local ANSI standards developers, and then you take all of the what we call consortia here, you're finding concepts moving at a rate of about 100 million per year. I think most of us are fairly familiar with the Green Building Council, but you probably didn't know that the Green Building Council is actually not a government agency. It's a branding organization. Same with the President's climate change commitment. These organizations emerged to meet a need for marketing, enforcement, and culture change. They most are typically proxies for incumbent interests that use code rules to drive the market for their product or service. They are essentially lobbying organizations in their effect. Now, just as ANSI standards developers provide standards to states and cities, the ISO and the ITU provide standards to entire nations, including our own. Of interest to us is the growing use of management standards, and that's the subject of another presentation. You might recognize ISO 9000. Suffice to say that these organizations also are producing hundreds of documents per year that govern such things as water, greenhouse gases, electrical power, everything we work with on our campuses. And of course, we're dealing with the states. In addition to those federal regulations, federal and state governments take about 8% of gross domestic product. Some states actually end up being test beds for federal regulations. We are a federalist system after all. There's some argument about that. But arguably, you'll see here in Michigan, it makes sense that it has a very heavy labor influence. I like to say that equipment and systems do not vote, the people who work on them do. Hence the preoccupation with labor in Michigan. California is the 8th largest economy in the world. It is very assertive in energy codes. Likewise with Massachusetts. As you might understand, New York is very involved in financial standards. So things are happening quickly, enabled largely by the internet. And I like to make a comparison with the way the U.S. standard system is evolving to the way Apple Computer forced the music industry to change. When Apple began selling music by the song rather than by the CD, or the package. It changed the music industry because it made artists create differently, but most important, it made the record companies sell differently. We can see an analog in this in the growing number of continuous maintenance standards developers who are opting to change their standards by the month rather than every 3 or 5 years as before. ASHRAE is the most aggressive among them, and I think Planet Blue got a taste of that last week. So here's a whole range of them. Many of them have to respond quickly. Let's say NSF has to respond very quickly to changes in water and food supply. I do not understand, however, somebody tell me why the Professional Ropes Course Association has to change their standards every 30 days. So now I like to make the scale of the regulatory action more concrete with a comparison to the problem that the British cryptographers reckoned with when faced with the Enigma machine used in Hitler's Germany. How the British were able to undo the Enigma code could only be done with a machine. If we're serious about mastering streaming regulation and changes in codes and standards, then we have to move at a scale unseen by the naked eye. The good news is that there is a possibility that social media and big data analytics are a resolution to this problem, helping us making the necessary synaptic connections to master the space. In other words, what the internet has done, we can undo. We can undo what the internet has done to us in the same way that Alan Turing was able to undo what the Enigma machine was doing to the Allies in World War II. But we're going to have to scale up and frame ourselves with going forward with a big data solution, and that's not hard to do. So you may ask, why don't trade associations do it? Well, a quick answer is that the tax code for 501c3 organizations generally prohibits it, but there are workarounds, as evidenced in the number of consortia that I showed you before. Those of you who are close to what we've been doing over the past few years, Jim Kennedy, John Lauder, Tracy, and others know that U of M co-founded APA's new Standard Council. Arguably, since Rich financed APA's first and only remaining vote on the NEC since 1995, we actually founded it. Whether or not they will claim that we founded it or not, it's not as important as helping them succeed. But we're going to have to lower expectations about what they can do and others like them can do, much of it owed to the sheer number of them. And I wanted to show you, again, this is another presentation, how many trade associations there are. Every branch of this organization chart has a trade association. So let's just focus on the facility planning and management branch, the one we're closest to, obviously, and you can see that there are, I picked 6 here, but there are many more. One thing here, I find this kind of interesting, that the National Association of State Facilities Administrators is NASFA, and the Association of International Educators is NAFSA. This organization here is one that is trying to put its umbrella over the hundreds of other trade associations in this same space. So even as we spawn trade associations, there's associations trying to capture what all the other trade associations are doing. That's America, that's competition. Of course, we know of APA, we're familiar with these organizations. So that's what it looks like in the, so that's what it looks like as far as the trade associations. Why, we can talk longer about the subtleties of why they're not able to help us, but how they can help us a little. If we go back to our macroeconomic view, we can see that the trade associations are a symptom of a larger problem of duplication. People in the education industry they'd like to educate, and there seems to be plenty of money to support gathering place business models. A more complicated problem, and the subject of another presentation, is the relationship between the lobbyists, the trade associations, and the incumbent interests, such as manufacturers, insurance, and labor, that are surrounding the trade associations. So some industries benchmark their effectiveness in patents per day, and I like to set a benchmark for one proposal or comment per day. In the past year and a half, we've fallen short of that. We've done other things, but we're short of that goal. But we have exceeded any other trade association or university that we know of, and we have the largest footprint in this space, and they all know it. Our objective is to work with all the trade associations to constructively to get all their ideas from the work point to the SDO. I like to use the term, one thing that I like to do, other than safer, simpler, lower cost, and longer lasting, we find a process that works, find its flaws, remove those flaws, and try to do it at half cost. So let's finish up here. 3 takeaways. I'd like everyone to use ANSI standards. Now this may seem odd to electricians who are using the NEC and plumbers who use the mechanical code. But whenever a new initiative is announced, whether it's recycling or security or resilience, do a little homework and research whether an entire standard or part of a standard already developed exists. We can reduce the cost of starting a new initiative from scratch. The federal government is prohibited from writing new rules of its own through OMB Circular A119, and the education industry should too. If you do not know if one exists, let us know, and we'll try to find one for you. If none exists, tell us, and we'll try to catalyze a trade association to write that standard, as we have with APA, the Simon Institute, ASHE, and IEEE. And if they will not do it, then we may write one of our own and offer it up to the industry so that our peers can avoid the waste associated with reinventing the wheels. Even if an existing standard is only partially adopted, it still saves significant resources. As I said earlier, the public sector in the United States does not have a strong tradition for management standards. The private sector has ISO 9000. The education industry, despite its claims for wanting to be international, is still a local operation. Large research universities accepted. Rich and I published an article in the ISO Journal back in January, and it's available on our website. You can get a little more detail there. I also wanted to let you know that that's where we continue our story. Visitors to our website over the Thanksgiving holiday might recall that we posted the American National Standard for the Dry Martini. We did that over Christmas, and we did that for a reason. I did this to let you know that some of the most humblest activities or products or services do have an American National Standard. So when you're called upon to make a martini over Christmas, you need not waste time experimenting with the right mix to get the authentic appellation-controlled cocktail drink. Please drink sensibly. Participate. We are making slow progress here. As I said, Planet Blue got a taste of this to write ANSI ASHRAE 90.1, the document that will be incorporated by reference into the imminent federal energy legislation. And then move swiftly. We shouldn't get too emotional about any new proposal coming out of a standards developer. Trust me, wait another hour and there will be another opportunity. Very often I can't help make the comparison with the instructions you receive when taking a college entrance exam. You can't get too emotional about any one concept if it's beyond your capacity. There are many more that lie ahead of you. We're looking to tool up with a pipeline that can be effective with about 80,760 concepts per year, or 1 per hour. In the era of streaming regulation, ferocious is the new fierce. We're not running a swell walk here. In the old world, the big fish ate the little fish. In the new world, the fast fish eat the slow fish.